Moving on to input and output. Now there are two types of input and output, obviously. There's console input and output to get things to and from the screen, and then there's file input and output. Let's start with consoles. Remove this one for now. You've already seen me using system out println in order to get things to the console. There are a few other ways of doing things, and above all we have to jump through a few hoops in order to get input from the console. Let's start an example. Yep, and in the main function there. And in this one, there are two different versions of doing this. One is, first of all, we want to include all the I/O library. We can of course include just the things we need, but let's use all of it and be lazy for now. The first one is we want to use an input stream reader. And we can use this one on the system in. We had system out, which we've been using, which is a print stream, and system in is a read stream. Problem with just using this is that we have to read character by character, and that's not really nice. So what we want to do instead is to use a buffered reader. And with this, we can print things like your normal. And if we want to read now, the problem with this is that these buffered readers, they are also you expect them to work with files and with network streams and stuff, which means that we have to have a try-catch statement around them. And what I get is I/O exception. And let's just print the arrow. Which will implicitly call the toString method, which I've talked about before, on the I/O exception. And what that's going to do is to give me a stack trace and some nice things. I can do some proper debugging on it. Now, let's read something. And now with the buffered reader, I have things like read line and stuff, which will allow me to read until I enter a new line. And then, of course, since I'm now within the try-catch block, this string response that I just created is only visible here, so I have to do something inside the try-catch block. Of course, I could declare the variable outside and then read it in here and then deal with all that, but for now I can just do things down here in here. And I can concatenate and be lazy about that. So this is one way of doing it. Let's see what happens if I run this inside here. And of course, since I'm running it from in a batch format, I can't really expect to get a particular output, so I have to go into a console for that. Where am I? And here we have the console I/O example. hello, and I can type something. And now it knows that I actually responded with something. Good, that's one way of doing it. Now let's go for the other way of doing it. There is, just like the system in and system out, there is an object called system console, or a variable which points to an object, which allows me to do things from inside there. So since I'm out of my block, I have to redeclare my response string. And from this console, this is an object that gives me ability to write input and output. With a prompt, which is rather nice. I want a space there as well. There we go. And then we can reuse that line and just say that we respond with something. Okay. What happened? Yeah, of course. What happened was I was trying to run this, and when I try to run this in a batch mode, there is no console. It's only available if I actually run it where there is a console. So if I run it here, and now I get the prompt that I used system console for, because now I have a console object. And now I can read things from the console, and I can write things to the console. Of course, what this means is that if I want to use system console, I have to check that I actually get something back from here. And if I don't, it'll throw a null pointer exception, because I'm trying to call a method on a null object, which of course doesn't work. So those are two ways of doing inputs and outputs. To the string, or to the console, should cover most of our needs for getting things. Normally it's system out println that we're using, and we will in a later video go through graphical user interfaces, so we don't have to do console input like this. But it's nice to know that we can do it. Moving on to files. Close that one. Let's do something on this with a file. Same thing here, start an example. There we are. And be lazy, import everything. And let's build up an array out of things as well. We might want to do that, or I know I'm going to use it, so. What do I want to do here? I want to have a main function, and in this main function I want to basically read a file and put it into an array. Just as with strings, I don't want to have an array that is statically declared and then I have to redeclare it every time I want to add a line to it, which is why I want to use an array list that I can append to, and it will grow dynamically until I'm done. So I want an array list of strings. and then I want to read a file. Reading files is always possible to get errors, which means that Java requires you to put a try-catch block around it. There's no way around this, you have to, basically. What you want to do with that error is up to you. You might just ignore it or just reprint it like this, but you have to catch it. So, a file reader is a nice way of doing things. And I can create that with the name of the file that I want to read, and since I happen to know that I just created a file called console.io example.java, let's put that in there. So file name, and I don't have to give that in the constructor, I can give that later of course. But now I have the same problem as I had with my input stream reader, is that I can only read a character at a time, and I want to deal with this file as a set of lines. So I need to put a buffered reader around this. And I'll give the file as an argument, which means that the buffered reader will work on this file. And actually, I could continue like this, but this means if I do it in this way, I am myself responsible for closing these two, the file reader and the buffered reader, when I'm done. And if there's an exception, I end up here, and then I have to find a way of making those variables, the file and the buff variable, available to me in this catch block in order to close them. And there's a finally statement I can use to clean up after myself. But that also means that I still need to clean up with the help of variables that I then have to declare outside of this try-catch block. So what I can instead do is I can use a try with statement, which looks almost the same. It's just that those variables, those resources that I'm going to use inside this try catch statement are declared within parentheses like this, and then comes the code where I actually do things with it. And I can create a line, and I can keep reading basically until I don't get anything more back, which is a while statement. And buff.readline will give me one line at a time from this file. We'll put that into the string line, because it's an allocation, it's not a comparison, and then we can do a comparison on that, like this, which puts everything into one neat little line, where I do both the allocation to line, and then I check if I'm done reading or not. What I want to do with this one? Well, let's do something fun with it. Let's create a string builder with this starting line, and then let's append something to my array list, which was called contents, and then let's just reverse this string. And when I'm done, convert it into a string, which will take line by line, reverse it so that it'll print it backwards, and then we'll put it into this array list of where I store my file line by line. like that, and once I'm done I can do some screen output just so I can see what happened. Run through the ArrayList contents and put the row by row, line by line, or element by element into the string L, and then execute this body. That should be runnable. Yes, it was. And as we can see, I've mirrored the file. I printed backwards, which is exactly what I wanted, of course. So that's reading a file. Let's do writing a file. I can put that into the same place. You can follow along. There are different ways of doing this. But first thing first, what we want to do is that we want to have a try with statement. And it's a file writer. And on top of this, because I want to write line by line instead of character by character, I put a Bufferedreader. Now, the beauty of putting these things into the try with statement like this is that once I'm done, or if there is an exception or whatever, Java will close them for me automatically. I don't have to worry about that because that's built into the try with construct. Let's run through this same contents array and write to my file. Write it and add a new line after each line, like so. And yeah, okay. Something like that. And this is a catch as well. And I'm not going to do anything with it. I could print it, of course, but I'm going to ignore it instead. So that's one way of doing a write to a file. Let's go into the shell and see. As you can see, there is no text file in there at the moment. And then let's run this. I still get the same output because I'm still doing system out print line, of course. But I should also have the output example file there now, which is the same thing. It's the file mirrored as I would expect, because that's what I put into the contents array list. Another way of writing to a file is to use a print writer. Same thing, try with. Nothing new there. And in this try with, let's put in print writer. like so. So I'm creating a print writer with the name of the file, and I'm calling the variable out. And now we can do the same thing. We can iterate over the contents array list, and we can just put that into the out. And now we actually have a method called println. So it looks sort of like system out. Like that. Let's run again. And now I have two files. The first one, output example, and the new one, which is called output example -pw. Which contains the same thing. So there are two different ways. These are two different ways of writing to a file. There are probably more. I can use different types of buffered writers and all sorts of fancy writers. But what Java calls it is that you put decorators around your basic stream. A buffered writer is one decorator that will give you some more fancier interface towards the underlying output stream that you have, and means that you can get to the level of the API that you want. You can have more or less advanced APIs, and you can use more or less the same APIs. I can use a buffered writer, a buffered print, a buffered reader on any type of stream. If it's a file, if it's the console, if it's a network stream, I can still use the same API in terms of buffered writer, buffered reader. So that's a nice idea out of it. But there are also, because Java has grown over the years, and people have added different ways of doing things. People weren't quite happy with one way of doing things. They added another way of doing things, and then another way of doing things again, which means that there are more than one ways to skin this cat. You can do different ways of console output and file output and network input output as well. So that's just the way it is. Pick one that you like, or the one that is predominant in the code base that you're trying to maintain, and then use that one. And that is what I wanted to say about files. If we summarize, we have system out, which is easy and it works sort of like expected. We have the system console, which is a method, which is important to remember. The console is a method that on system that will return a console object, and on this object we have, for example, a readline method. So we can do system console .readline if we have a console. If we don't have a console, this is going to give me an error because I'm trying to call a method on null. So I have to take care of this. What else did we do? We did try the try catch. I did mention that there is a try catch finally. And the one we actually decided to use was the try with. Which is nice because it closes things for us. Reading and writing is, as I said, plenty of different ways. And these are just a few examples to get you started. And that is what I wanted to say about input and output.